If we go by definition for SPF record, an SPF record helps an organization from receiving spoof or phishing emails. But the question arises, how does SPF do it? Let's assume that we have two different organizations, abc.com and xyz.com. One of the users from abc.com, Bob at abc.com, wants to send email to a user in xyz.com. So Bob at abc.com will compose an email and will type the email address of John at xyz.com and will send that email from his email application. Now, as soon as this email will be sent from Bob at abc.com email application, that email will be processed by one of the email servers within abc.com organization. And during that process, few attributes will be added within the email header of that email. For example, connecting IP address, from address, to address, and return path. Where connecting IP address will be the IP address of the sender's email server, which is going to process that particular email. And the return path will be bob at abc.com. Return path is the email address to which an NDR or bounce back message will be sent in case the email is not delivered to the recipient. So now this email will be sent to john at xyz.com and it will be processed by the email server of xyz.com organization. Recipient server will try to find if this particular email is a legitimate email or not. But the question is how recipient server will trust this email if the sender of the email is the actual owner of abc.com domain. Or how recipient server will verify if the IP address 1.2.3.4 is the IP address of the sender's email address. Let's consider one more example. Let's assume that we have two organizations, abc.com and xyz.com. Now, someone who does not belong to abc.com or xyz.com organization is trying to send an email using abc.com domain. He will use bob at abc.com email address and will send that email to john at xyz.com. Now, this email will not be processed by the mail server of abc.com because this email is not sent from the mailbox of bob at abc.com. So this email will be processed by a random server. And during that process, few attributes will be added within the email header. The connecting IP address will be the IP address of this random email server, which is going to process this email. And the return path will be the email address of the guy who is going to send this email using abc.com domain. So when recipient server will receive this email, that server will try to find or will try to validate if this particular email is a valid email or not. But how recipient server will come to know if the connecting IP address 12.12.12.12 belong to abc.com organization? Or how recipient server will verify if this particular email was actually sent from bob at abc.com? So now let's understand how SPF record will help the recipient servers to identify if the email is a legitimate email or it is sent by somebody who does not belong to that particular domain. So now we will see how things will change when SPF record comes in the picture. Let's assume that abc.com organization has now added an SPF record for their domain in public DNS. And the IP address of their email server is added within the SPF record. Now, bob at abc.com will send another email to john at xyz.com. And when this email will be sent, it will be processed by one of the email servers of abc.com. And during that process, few attributes will be added within the email header. For example, connecting IP, which will be the IP address of the email server of abc.com. And the return path will be bob at abc.com. When this email will be sent to the recipient server of xyz.com organization, that email server will try to find whether this email is a legitimate email or not, or whether this email is actually sent from abc.com domain or not. To validate whether this email is a legitimate email or not, the recipient server will check the return path and it will extract domain name from the return path. And then it will reach the public DNS of abc.com domain. The recipient server will query the public DNS that do you have SPF TXT record for abc.com domain. Public DNS will show the SPF record for abc.com domain, and the recipient server will check if the connecting IP address is added within the SPF record or not. If the sending server's IP address will be found within the SPF record, SPF check will pass and the email will be delivered to john@xyz.com. And in case the sending server's IP address is not found within the SPF record, in that case, SPF check will fail and the recipient server will treat this email as per the action specified within the spam filtering policies. So now if john@xyz.com will forward this email to an external user, in that case, SPF check will fail because SPF check will be done against xyz.com domain who has forwarded that email. This is one of the limitations in SPF record, that it doesn't work or it gets fail when emails are forwarded to other users who are external. There are lots of scenarios where SPF record is used to stop spoofing and domain impersonation. Let's consider one more example and things will be more clear. Let's assume we have an organization abc.com and this organization has an application that sends emails to external users or to external domains. And this application uses one of the user accounts email address of abc.com and it sends emails using that particular email address. When this application will send an email to recipient, the recipient server will check the connecting IP address and the return path within the email address. Then recipient server will query the public DNS for SPF record for abc.com domain. If the SPF record does not has the IP address of the application, in that case SPF will fail and that email will be marked as spam by recipient filter and the category of that particular email will be spoof. To overcome this situation, what sender can do, he can add the IP address of the relay application within the SPF record of abc.com domain so that the recipient servers can trust that particular email. Once you add IP address of the relay applications within SPF record, all the recipient servers will treat that email as a legitimate email and they will trust that this particular email is sent from abc.com domain. Now let's understand how we create SPF record and then I will be showing you how we can add SPF record for our custom domains. In Office 365, SPF record value will always be v equal SPF1 include spf.protection.outlook.com -all. An SPF record has three components: version, SPF value, and enforcement rule. Version specifies the version of SPF record. An SPF record will always start with this particular value, v equal SPF1. SPF value defines the IP address or the domain name for which you are adding the SPF record. In this example, spf.protection.outlook.com indicates that the domain for which you are adding SPF record is added within an Office 365 tenant. If you want to add an IP address in SPF record, then value will be v equal SPF1 IP4, and then you will be specifying the IP address of your application or the server, and then you will be typing include spf.protection.outlook.com. So in this particular SPF record, IP address is the IP of your email server or an application, and spf.protection.outlook.com indicates that the domain for which you are adding this SPF record, that domain is verified in Office 365 tenant. Enforcement rule is of three types: hard fail, soft fail, and neutral. Hard fill enforcement rule indicates that I have only one server from where my users will be sending the emails, and that server name or IP address is added within the SPF record. Soft fill is used when we are not sure how many email servers we have in our organization. That means I'm not sure that from which server my users can send emails, and I haven't added all the servers or the IP addresses of all the servers within our SPF record. Neutral is reserved for testing purposes. This type of enforcement rule is not used in the production environments. To add an SPF record, you need to update a TXT record within the DNS management of your public DNS. This particular domain, office365concepts.com, is purchased from GoDaddy. So if you have purchased a domain from GoDaddy, the benefit is you don't have to add DNS records manually. As soon as you will add a domain in Office 365 tenant, all of the DNS records will automatically add within public DNS of GoDaddy portal. But for this demo, I have removed SPF record so that I can show you if you have to add it manually, so how it can be added. If I go back to the DNS management under Office 365 Admin Center for this domain, office365concepts.com, I can see that almost all of the records are already updated. But the TXT record, which is for SPF record, is not added yet because I have removed it manually. This will be the value for the SPF record. You can copy the value from here and go to your public DNS and create a TXT record. So we will select TXT because the SPF record is a TXT type record. So here we will mention at, and then we will paste the value that we have copied from Office 365 portal. And then we will click save. When you will add this particular DNS record, or if you will add any particular DNS record, you will have to wait a couple of minutes so that it can be replicated. To verify if a particular DNS record has been updated or not, we can go to command prompt, and here we can perform nslookup query. We will type nslookup set q equal txt, and then we will type the domain name for which we are going to query this particular txt record, which is office 365 concepts.com. So here we can see SPF record has been replicated. There is another way you can verify, which is MX Toolbox. From mxtoolbox.com, you can verify all the DNS records. You can check if particular DNS record has been replicated or not. So here we will type txt and then we will type the domain name. So that will be txt and the domain name. We will perform lookup. And here we can see SPF record has been published. Now let's recap what we have done. If we go by definition, DKIM is an email security standard which is designed to make sure that emails are not altered during transmission between source to destination. As soon as an email is sent from the sending server, DKIM signs that email using a private key. But the question arises, how exactly DKIM does this? In last session, we discussed if emails are forwarded to external users, SPF gets fail. Because when email will be forwarded, the return path value will change and the SPF check will be performed against the domain who has forwarded that particular email. But DKIM adds digital signatures within the email header. And even if email is forwarded to a different organization, the signatures will be preserved within the email header. To enable DKIM for a domain, we add two CNAME records in our public DNS. These CNAME records are used as a public key by the recipient email servers to verify if the email's body hasn't changed during the transmission. Once the signatures are verified by the recipient email server, DKIM will pass and the email is treated as authentic email. Now let's understand how DKIM works and how it signs emails with digital signatures. Let's assume that we have two organizations, abc.com and xyz.com. And abc.com organization has added DKIM records in their public DNS. When an organization enables DKIM for their domains, the private key is securely stored on Microsoft servers. And all the emails sent from that particular organization are digitally signed using this private key. When abc.com organization will send an email during this process, this email will be digitally signed by DKIM signatures. When xyz.com email server will receive this email, the recipient server will extract DKIM signatures from the email header and will reach public DNS. xyz.com email server will ask DNS for the public key which is published by abc.com domain. Once recipient server has the public key, the recipient server will validate the email using the public key. If the email validation is successful, DKIM will pass. And if email was altered during transmission, DKIM will fail. Now let's understand how we can create DKIM records. This is the syntax of DKIM records. Before we create a DKIM record, we should be aware of the MX value for the domain you want to enable DKIM. And the second value that we need is Office 365 initial domain name. For this demo, I will be enabling DKIM for Office 365 concepts.com domain. So for this domain, MX record value is Office 365 concepts-com.mail.protection.outlook.com. And the initial domain for my tenant is 365 conceptslabs.onmicrosoft.com. To create DKIM record, we will replace domain GUID with the domain name as it is showing in MX record. For example, Office 365 concepts-com. And initial domain will be replaced with your initial domain name, which ends with .onmicrosoft.com. Once you have these DKIM values, you are ready to add them within your public DNS. When you publish DKIM records in your public DNS and when DKIM is enabled for your domain, all of the outgoing emails will be digitally signed using the private key. If you analyze an email header, you will see a value similar to this. A typical DKIM signature looks like this. These header values are added within the email when your outgoing emails are digitally signed with DKIM private key. Now let's break this header and let's understand what these values mean. DKIM-signature indicates that the email is digitally signed using DKIM private key. V=1 indicates the version of DKIM being used by the server that has sent this particular email. R=RSA-SHA256 indicates the algorithm which is used to sign this particular email. There are two supported signature algorithms to sign emails, RSA-SHA1 and RSA-SHA256. D= indicates the domain name that has signed this particular email. S=selector1 indicates the name of the selector that will be used by the recipient server to validate this particular email. The next values that we can see within this signature from date, subject, message ID, and MIME version. These are the headers that were included within the email when this email was digitally signed. So guys, now let's understand how we can enable DKIM record for our domains in Office 365. For this demo, I will be enabling DKIM record for Office 365 concepts.com domain. And to enable this, I will switch to the domain provider website. Under DNS management for Office 365 concepts.com, I will be adding two CNAME records. The type of the record will be CNAME and the host will be selector1 dot underscore domain key. I have copied these values in a notepad. So this is the syntax of DKIM record that I have replaced with the domain name, which is reflecting in the MX record. And this is my initial domain. So I'm going to copy this value and I will paste it here and then click save. In the same way, we will create one more CNAME record. Domain type will be CNAME. And this time selector will be selector2 underscore domain key. And the value will be the one that we have copied. Selector2 dash your domain name and then initial domain and click save. When you add DNS records, wait for 1 or 2 minutes so that these records can be replicated. Once we have added DKIM records in public DNS and when these records are published, after that we can check DKIM signing configuration with the help of PowerShell commands. And for that we will run get-DKIM signing config -identity and then we will type the name of our domain and pipefl. With the help of this command, we can check the configuration settings of DKIM record for a particular domain. Selector1 key size is the bit size of the key which will be used to sign the digital signatures on a particular email. If for any reason this key size shows 1024, in that case, you would need to increase it to 2048 bit because 1024 key is less secure than 2048. These are the digital signatures which will be stamped on your emails, which will be sent from your organization. The algorithm which will be used to sign the emails, that will be RSA-SHA-256. To increase the key size from 1024 to 2048, we will be running rotate-DKIM signing config -key size 2048 -identity, and within identity we will copy this GUID value and will paste here. With the help of this command, you can increase the key size for a particular DKIM signing configuration. If I press enter, I may receive an error because this is already showing 2048. So by running this command, you can increase the bit size of the encryption key, which will be used within DKIM signing configuration. Now let's recap what we have covered in this particular session. Domain keys identified mail is an email security standard which is designed to make sure that emails are not altered during the transmission from source to destination. As soon as you send an email, DKIM uses public key cryptography to sign that email with a private key. DKIM signatures are preserved within the email even if emails are forwarded to other organizations. DKIM only signs the emails digitally. It doesn't encrypt email contents. If your requirement is to encrypt email contents, then you should use Office 365 email encryption or OME. If you go by definition, DMARC helps the recipient email servers to determine what action they should take on your emails if SPF or DKIM checks fail. DMARC works with SPF and DKIM. Before you enable DMARC for your domains, you must need SPF and DKIM records to be published for that particular domain. Let's consider an example and let's understand how DMARC works. Let's assume we have two organizations, abc.com and xyz.com. abc.com organization has published SPF, DKIM, and DMARC records in their public DNS. In this demo, abc.com is going to send an email to xyz.com organization. When this email will be sent to xyz.com organization, their email server will perform few checks to validate if the email is a legitimate email or not. Recipient server will first extract the domain name from return path, and then recipient server will extract domain name from address and will match both domain names. This is called SPF alignment. If both domain names are matching, SPF will pass. If domain names are not matching, SPF will fail. And if SPF alignment fails, recipient server will now check DKIM validation. Recipient server will check the domain name within D equal attribute and will match that domain with the domain name extracted from the from address. D equal is a value that is found within the DKIM signatures, which indicates which domain has signed this particular email. If both domain names match, DKIM will pass, else DKIM will fail. Now, if either SPF or DKIM check fails, recipient server will treat that email as per the action specified by the sending server within the DMARC records. This is a standard DMARC record. Let's break this record and let's understand what each component means. V equal DMARC1 indicates the version of DMARC record that sender email server is using. P equal stands for policy. Under policy, we specify the action that recipient server will take in case SPF or DKIM or both records will fail on your email. Under policy, we can define three actions: none, reject, and quarantine. If you have specified action none, that means recipient server will not take any action and email will be delivered to the recipient. If you have specified reject action, in that case, the recipient server will reject this email if SPF or DKIM or both will fail. If policy is set to quarantine, the recipient server will redirect that email to their quarantine portal. PCT equal is the percentage of the emails to which the domain owner would like to have its policy applied. If it is set to 100, that means all emails sent from this particular domain will have P equal policy applied. RUA equal mail to is the email address of the mailbox to which reports should be sent for further analysis if SPF or DKIM fails on your emails. Now let's understand how we can add DMARC record for our domains in Office 365. For this demo, I will be enabling DMARC for Office 365 concepts.com. And to add the records, I will switch to the domain provider website. Under DNS management, I will be adding a DMARC record. The type of the record will be txt. Host will be underscore DMARC. And the value will be, first we will specify the version because which is V equal DMARC1. Then we will specify policy P equal. So we can specify three types of policies: none, reject, and quarantine. So as per your requirement, you can specify any one of these three policies. For this demo, I will be typing reject, and then we will mention PCT value, which is percentage value, and I will go with 100. Okay, so we have mentioned version, policy, and percentage value. And then we will click save. To validate these records, we will switch to DMARC record analyzer. On this website, we will type the name of our domain, Office 365 concepts.com. And we will validate if this DNS record has been populated or not, has been replicated or not. So if we scroll it down here, we can see the DMARC record has been published. This is the record that we have added within the DNS provider, DNS management. This is the version, this is the policy, and this is the percentage that we have defined within the DNS record. Now let's recap what we have understood about DMARC. DMARC works with SPF and DKIM. Before you enable DMARC for your domain, you need to publish SPF and DKIM records for that domain. DMARC provides additional protection against spoofing and phishing emails. By defining policies, we can tell the recipient servers what action should they take if SPF or DKIM or both records fail on your emails. With DMARC, we can forward emails to an email address, and those reports can be used for further analysis.